Hello and a very good day to Dr. Zarafi. My name is Munchin Fai with the matrix number AE190091 from Group 5 of Section 1. In this part of the video, I shall be presenting the introduction, which consists of other little subtopics. Well, without further ado, I shall begin my presentation. So for the background of the project, nowadays automation is slowly becoming a part of humans' daily lives. Many industries, no matter how big or small, have started to use robots in their lines of work. This is due to robots' reliability and being of great assistance to humans. Obstacle avoiding robots have been invented for the same reason, as they are hard to reach places for humans or when the robot is not manually controlled by humans, and the robot has to figure out its own pathway by itself without getting stuck. Obstacle detection is the essential to this autonomous robot, and the robot gets the information from its surrounding area through sensors that have been mounted on the robot, which can be bump sensors, infrared sensors, ultrasonic sensors, and many others. Our group has chosen an obstacle avoiding robot as it fits the criteria for the project given, which is designing a DC mini electric motor system. Next, the scope of the project. The scope of the project is that the obstacle-avoiding robot has been chosen and will serve as a template for our project to design a DC mini electric motor system which needs to be able to avoid obstacles on its own and move according to the racetrack given in the project's instruction sheet as a complete full cycle. Next, for the objectives of our project. There are several objectives that we wish to attain during the entire course of this project. 1. To design a variable speed DC drive for a small-scale DC mini electric motor model application. Secondly, to demonstrate the electrical drive system for a mini EV model application. And thirdly, or lastly, to be able to work in a group to solve a complex engineering problem. Hence, here we are at literature review, which is the last part for our introduction. Research has been done on the subject of obstacle avoiding automatons recently, as robots have slowly seeped into humans' daily lives for the past few decades, and robotics have become the centerpiece of study amongst scientists and engineers alike, as robots have become a common sight in most industrial or manufacturing workplaces. An obstacle-avoiding robot is designed which can detect obstacles in its path and maneuver around them without making any collision, and the development of an obstacle-avoiding robot model is required as a fundamental step towards a bigger goal. For example, the development of an autonomous vehicle. An obstacle-avoiding robot uses a proximity sensor module. The robot is controlled by a program that is embedded into a microcontroller. So for example, by using an Arduino microcontroller and ultrasonic distance sensors, a robot vehicle would be able to detect obstacles. So as a closure to the literature review, we were able to witness that obstacle avoiding robotics is slowly becoming more important and that more research and development is progressively being made so that and advancements on the technology can be realized. That is all for my part. Thank you very much.
A very good morning to all the lecturers who is watching this video presentation today. My name is Lee Jin Zoe. I'm going to present a you about the methodology part in our project. So the first part, it should be a simple block diagram design. The design for the component of DC mini electric model. We have PC, microcontroller or Arduino, and ultrasonic sensor, power supply, and several models. And the basic arrangement of the equipments to make a DC mini electric model is as this one, simple block diagram where the power input and also the ultrasonic sensors is connected to a microcontroller. and the microcontroller is to the motor driver, and the motor driver to serve the model to the servo model. And the next part, it should be the Arduino coding design after the simple block diagram. We're planning to do the flowchart fine before doing any coding. So the flowchart is used to visualize the calling sequence and the relationship between the functions. And the corresponding flowchart has been shown as here, the Arduino coding design. So from the starting to initialize ports and forwards if there is no, or if there yes, go back the set of direction of robots forwards, right, left, or backward, and to its obstacle is detected, yes or no. If yes, move forward. If no, go back again the set direction and then stop. And the last part is the simulation design of our this project. So we're using the protest software to design the motor DC mini electric motor. And the component of the simulation design include the Arduino UNOR3, a power source L2390 model, model PWM servo, and ultrasonic sensor as shown at here. So that is all from my methodology part. Thank you very much. Thank you your attention.
Hello, it's me, Punchun Fai again, here to introduce a little on about our obstacle avoiding robots electrical circuit design in Proteus. So over here we have the uh, electrical circuit design being laid out in Proteus software. So at the top here we have the ultrasonic sensor. To the right here we have the servo motor, which drives the ultrasonic sensor so that the ultrasonic sensor can move around to detect things that is surrounding the robot. So the black ones here are also motors. These motors drives the wheel on the robot. So what drives the wheel are the L293D motor driver and also of course, the centerpiece Arduino microcontroller. So thank you so much for watching this video. Thank you. That's all from me.
A very good day to Dr. Zarafi. My name is Daniel Ganifan, AE19007. I'm from Group 5, Section 1, Electric Drive BEV30703. Today I'm going to do a presentation on the electrical coding of electric vehicle, which we're using Proteus simulation. And as you can see, we're using ultrasonic sensor, integrated circuits, and the hydrogen node, which we're going to include our library first, which is servomotor and wire, which is we can include our library over here, manage library. Yes. And I'm going to define my trigger pin 9, echo pin 8, which is a ultrasonic sensor, and LED pin is for 2, motor pin 1 is for 7, motor pin 2 is for 6. So I'm going to serial begin my integrated circuit, which is a 9700 bits rate, and we're going to attach the third servo motor in a 10, which the pin mode with the trigger is all output over here, and we're going to use our loop is a long distance and a distance, which we'll write a trigger pin low, delay 2 seconds and 2 microseconds, and the other one will be high and will be 10 microseconds. Okay, so for distance will be increased in duration divided by 2 over 29.1, and when use if else row, if the distance is less than equal to 0.20, the LED will become high. The position will move from 100 degrees to 0 degrees. Okay, and for the digital write of the LED when high, the motor pin 1, 2 will become low. Okay, and position will become 0 degree to 180. Else for the LD will become low, and the bottom 1 and 0 is high and low respectively. Thank you.
Assalamualaikum dan selamat sejahtera. My name is Tajwani binti Abdul Halim, AE10045, and I will present about the outcome of the project. Okay, this is our final simulation of an obstacle avoiding the robot. For the outcome of the project is for the first test data, we have to design a DC mini electric motor system, and the design in Porteous software successful, and the result was passed. For the second test data, we have to control the robot using an Arduino as microcontroller, and the interface module translate microcontroller logic into voltage and current that can drive the two motor, and the result was passed. For the third test data, connect the ultrasonic distance sensor and a robot be able to detect obstacle, and the result was passed also. Okay, for the fourth test data, using an Arduino software to carry out the programming, and Arduino software can run the program was passed. And the fifth, using an integration of ultrasonic distance sensor, we have to provide a higher accuracy in detecting obstacle, was passed also. And the sixth, the test data, the drive motor first was low and the drive second motor was low in program. So LED was turning on the light, and the motor from 180 degree turn to 0 degrees, and we have passed this test data. And the seventh test data, the drive motor first motor was high and the drive motor second motor was low in program, and LED was turning off the light, and the motor 0 degree turn to 180 degree. Then delay 5 seconds to reach the position, and the result was passed. Okay.
A very good morning. My name is Suzy Sen. My number is AE19093. Now I continue with my result and discussion part. According to the flowchart previous out the coding of Arduino as below. So this is a copy. After that we load the code into the Arduino Uno, and then test it, and then we start the simulation as below. So this is our simulation. So we start it, and then as the wheel starts to run, the servo motor start to rotate slowly, and then the servo motor will change the direction anti-clockwise when facing any obstacle due to the command of the microcontroller. If there is no obstacle, the servo motor will still continue to move in its direction without changing any direction. So this is all for me. Thank you.
We continue with the conclusion. With me, Nurshahani binti Abdul Halim, AE10045. Okay, the project for this conclusion from this project, the project has been complete with success, and the project presents a simple, low-cost obstacle detection and servo motor for the movement of robots. For the second conclusion that we got, the autonomous system evaluation revealed that it's capable of avoiding obstruction, avoiding collision, and changing its position when it's detect the obstacle. Okay, for the third conclusion that we can conclude, the project show that the design has more functionality that can be added to produce several functions with less or no interference from human. Okay, the last, the obstacle avoiding robot may help shielding unfriendly environment, and the country can be safe with the security sectors. Okay, that's all from us. Thank you.